Hello there. My name is Michael Kamanga, and I'm back with another lesson. Well, in today's lesson, we are going to look at the physical changes. Physical changes. So be with me. Um, by the end of this lesson, our success criteria is you should be able to describe physical changes. Describe physical changes. Um, Basically, substances do react when they are mixed with the others. They may also react when they are exposed to conditions such as heat and pressure. A good example is the ice. When ice is exposed to heat, it changes from solid to liquid. And when a substance reacts, basically it changes into a different substance. That is, a substance which reacts is simply called a reactant. Now, briefly, after a reaction, the substance formed is called a product. So you are starting with a reactant, it will react, then it will produce a substance which is known as a product. So a statement that shows reactants and products of a reaction is called an equation. So an equation, it gives a summary of reactants changing to products, and sometimes vice versa. So a good example is the melting of ice. In melting of ice, I will take you through that is what happens as ice is melting. So when ice is melting, I'll give you a description of what really happens. So from there, we'll be able to learn what exactly happens when ice is melting. So be with me. In melting of ice, we need the following materials. That is the ice cubes, a heat-resistant glass or plastic container. We also need a thermometer, a stopwatch, paper towels for any spills, a ruler, but this one is optional. The procedure is like, first of all, preparation. So in preparation, we'll place a few ice cubes in the container, and then we ensure that the container is at room temperature and dry before adding the ice cubes. And the initial observation is that you're supposed to record the initial temperature of the ice cubes using the thermometer. So you dip the thermometer in the ice cubes and you record the initial temperature. From there, you have to observe the physical state of the ice cubes and note their shape, size, and other physical properties. Then optionally, measure the size of the ice cubes using the ruler. Then from there, melting point observation. You are supposed to leave the container with the ice cubes at room temperature. What is room temperature? State room temperature. Yes, it's 25 degrees Celsius. So you have to start the timer or stopwatch to monitor the time. You observe the ice cubes as they begin to melt. Periodically measure and record the temperature of the melting ice, that is every few minutes. Then you note the physical changes such as the ice cubes decreasing size and the formation of liquid water. And the final observation, you have to continue observing until all the ice has melted completely, leaving only liquid water in the container. You have to record the final temperature of the liquid water because initially you recorded the initial temperature. So here you are recording the final temperature of the liquid water. Then you note the time, that is the total time it took for the ice to melt completely. So from that, the analysis is that the physical state change. So you discuss how the ice transitioned from solid to liquid and how this is a physical change, as the chemical composition of water remained the same. So you give a justification to that. Then temperature consistency. You note that during the melting process, the temperature of ice water mixture remains constant at 0 degrees Celsius or 32 degrees Fahrenheit until all the ice has melted. This demonstrates the energy absorbed by the ice is used to break the bonds holding the solid structure. So yes, the energy which was absorbed was used internally to break the bonds. Then the reversibility emphasized that if you were to place the liquid water in a freezer, it would refreeze into ice, showing that the physical change is reversible. So this is a key point. What is a characteristic of a physical change? You have the answer there. It is reversible. As you can see, reversibility there. Then to conclude, this experiment demonstrates that melting ice is a physical change, as the process involves only a change in the physical state. And which physical state is this? Which change of physical state is this? Changing from solid to liquid. Changing from solid to liquid. So it involves a change in the physical state of water from solid to liquid without altering its chemical composition. The chemical composition of ice, the chemical composition of water remained intact, untampered with. Then the experiment also highlights that physical changes are generally reversible. So yes, this is one of the characteristics of a physical change, reversibility. Now, in this description, in this experiment, you have the following safety notes. This experiment is safe for all ages, but should still be conducted with care to avoid spills or slipping on any melted water. Please take notes. Remember lab safety reminders. In the lab, we have general laboratory safety rules. Keep those in mind. So, in melting of ice, okay? In melting of ice, as you can see, in the forward arrow, that is melting process. So the melting process requires energy. It requires energy. So you can heat or you leave the ice. So long they absorb heat, they will start melting. Why are they melting? Because there is change of state of matter. That is from solid to liquid. So energy is involved. Now, as we are moving from the liquid water to form the initial ice, as you can see, the process releases energy. You bear me witness that whenever you want to freeze liquid water, you put the liquid water in a refrigerator. And in a refrigerator, the temperature is lowered. So there's release of energy. There's a release of energy. So as ice is melting, as it is changing from liquid to solid, energy is released. And the converse is true. As ice is changing from solid to liquid water, there is energy taken in. So the process indeed requires energy. In freezing, the process releases energy. So as you can see, this is a physical process. So the melting of ice is a classic example of a physical change. And during this process, solid ice transforms into liquid water. Here is how this physical change occurs. So I'll take you through this process of a physical change. The melting of ice, it is not the only example of a physical change. There are so many examples of physical changes. This is just one of the examples. I hope you do understand. Well, the first stage is the initial state, that is solid ice. So the solid ice, the structure of solid ice, it is solid at room temperature. It is in solid form. Water molecules in ice are arranged in a liquid crystalline structure where each molecule is held in place by hydrogen bonds. This structure gives ice a solid, stable shape. Temperature: ice is typically at or below 0 degrees Celsius, which is its freezing point at standard atmospheric pressure. Process of melting: first of all, there is heat absorption. When ice is exposed to a temperature above 0 degrees Celsius, it begins to absorb heat energy from its surroundings. So this heat energy is not used to increase the temperature of the ice, but to break the hydrogen bonds between water molecules in the solid state. Please take note of that the ice, whenever it is exposed to temperature, it absorbs, it gets it in heat energy from the surrounding. So this energy is used to increase the temperature of the ice. Then there's phase transition. As these bonds break, the rigid structure of the ice begins to collapse. Which bonds are we talking about? The bonds which are holding the ice particles together, so that the ice should maintain its solid state. So the energy which initially has been absorbed by the ice, it will be used to break the bonds. So the water molecules start moving freely now. The ice gradually transitions from a solid to a liquid state, forming liquid water. Then from there, physical changes in chemistry are processes that affect the form or the state of a substance without altering its chemical composition. Reaching this far, I hope you now understand what a physical change is. Because here we're just mentioning about the physicality of a substance changing via physical processes, melting, freezing, for example, and not changing the chemical composition of the substance. So the chemical composition is untampered with. It remains the same. So a physical change, it indeed only deals with the physical nature of a substance. So what are the key characteristics of physical changes? First and foremost, there is no formation of new substances. So in a physical change, the substances involved remains the same at the molecular level. There is no new chemical bonds formed, so the identity of the substance does not change. It will always remain the same. For example, when ice melts into water, both the ice and water are composed of water molecules. There's no any change. There's no any chemical change. The water molecules will remain the same. Then, another key characteristic of a physical change is that it is reversible. So many physical changes are reversible. The original substance often be recovered by reversing the conditions that caused the change. For example, water can be frozen into ice and then melted back into liquid water. As you can see, the process is reversible. Water, ice changing to water, water changing to ice. So it is a reversible reaction. From that, can you define a reversible reaction? Yes, indeed. A reversible reaction is a type of reaction that goes both ways. Reactants forming products and products can form reactants. They can react and form products. So that is just a simple definition of a reversible reaction. Then change in physical properties. So physical changes often involve alterations in physical properties such as shape, size, color, state, density, or volume. There's an example there. Tearing a piece of paper changes its shape and size, but it remains a paper by the end of the day. Energy involvement in a physical change. Physical changes may involve the absorption or release of energy, but this energy only affects the physical state. That's all. It affects the physical state from solid to liquid, liquid to gas, or gas to liquid, liquid to solid, and so on and so forth. For example, heat is absorbed during the melting of ice, but this energy only facilitates the change from solid to liquid. In a physical change, there is no change in chemical composition. So the internal structure of the molecules remains unchanged, and the substance retains its chemical properties. For example, grinding a sugar cube into powder changes only its appearance, but it remains chemically identical to the original sugar, and it ends there. So the physical properties, yes, they are altered, but the chemical properties are never altered. Then there's also phase change, or if you may wish, change in state. So changes in the state of matter are all examples of physical changes. You talk of freezing, vaporization, condensation, sublimation, to mention but a few. For example, boiling water changes it from a liquid to a gas, but the substances remains water. Then in a physical change, it is temporary in nature. So usually physical changes are often temporal, meaning the original state of the substance can usually be restored. They can be restored. For example, stretching a rubber band is a temporary physical change. It returns to its original shape when released. There is no new energy levels. The energy changes involved in physical changes, they do not alter the energy levels of the electrons within the atoms or molecules of the substance. For example, heating iron causes it to expand, but the energy levels of its atoms remain the same. You may wish to give more examples on this. Yes, bring them in the comment section. There is no problem. So, in summary, physical changes are characterized by alterations in the physical form, state, or appearance of a substance without changing its chemical identity. These changes are typically reversible. They do not result in the formation of new substances, and they involve changes in physical properties like state, shape, and energy, but not in chemical composition. So, in a nutshell, to summarize, a physical change, in a physical change, we are only changing the physical nature of a substance. We are only changing the phase. We are only changing the state from liquid to gas, gas to liquid, liquid to solid. So all the physical process, sublimation, freezing, condensation, melting, deposition. And in a physical change, yes, energy is involved, but the energy does not change the chemical nature of the substance. So the chemical nature of a substance is always maintained in a physical change. There is no any alteration in the chemical nature of a substance. For example, as you are melting ice, or burning of a candle, yes, burning of a candle. If you burn the candle, it will melt, liquid form. But with time, it will freeze. It will go back, that is from liquid to solid. At first, the change was solid to liquid, melting. But with time, it will be liquid to solid. So this is a clear example of a physical change. And from the example which I've given, you can be able to deduce that a physical change is reversible. It is reversible. Ice, melting of ice. So solid ice will melt to liquid ice. Liquid water. And this process will involve energy. And furthermore, the liquid water can go back and form solid ice. and this process will release energy. So this as an example of a physical change, it simply tells you that a physical change is indeed reversible. It is reversible in nature. Can you give me more examples of physical properties, rather physical changes? You can provide them in the comment section. You are always welcome. Now, can someone summarize? Can you summarize what have you learned in this lesson? Can you summarize? Good. I hope you have summarized it in this way. That in today's lesson, we have looked at reactants in a chemical reaction, products in a chemical reaction. And we have also looked at physical change. We have defined what physical change is. We have given examples of physical changes. And we have also looked at the key characteristics of a physical change. And we have also looked at the melting of ice as an example of a physical change. Good. Now, having done that, now let us look at the activity for the lesson. Feel free to provide your answers in the comment section, and feel free to compare your answers with my answers, and ask more questions via the comment section. Now, the first question is, what is a physical change? What is a physical change? Then how does a physical change differ from a chemical change? And what happens to the chemical composition of a substance during a physical change? Then can a physical change be reversed? Provide an example. Is the boiling of water a physical change? Why or why not? Why is melting ice considered a physical change? And what are some common physical changes that occur in everyday life? Then lastly, does a physical change affect the mass of a substance? Why? Well, this marks the end of our lesson. I hope you have enjoyed the lesson. Thank you. And if at all you have any questions, please, there's a WhatsApp number. And you can also go to help@xulendo.org. You can also visit Xulendo online and xulendo.org. If you may wish, in today's lesson, these are the resources which I have used. Excel and Succeed, that is the Junior Chemistry Book 1. Achievers in Chemistry, Book 1. Django Chemistry, Book 1. Samuel Kalea, that is Chemistry, Book 1. So again, I've also used photos, and if you may wish, you can also click the links to check the sources of these photos. Don't be limited to these resources. There are so many resources. You can go on the internet. You can also look for more books so that you should supplement on the information which you have been given. I thank you for going through the video. Until we meet next time in the next video.